I would say that first of all, modeFRONTIer allows to enhance the efficiency of AI/ML models by integrating the simulation workflows with design of experiments, response surfaces, methodologies, and reduced order models at the same time. I mean, once you have built your workflow, you can develop easily your DOE and use it to train RSMs and run ROM inside modeFRONTIer. A second point that I would like to mention is related to the reuse of existing data. I mean, it is important to reduce the need for new simulations every time that you have to train a model. So having a way of efficiently reducing the number of needed simulations without losing the accuracy of the final model is of paramount importance. After that, I would like to mention also that the interpretability of the trained model is really important in the context of AI/ML models, applied especially to engineering optimization. What does it mean, interpretability? Every time that you train a model, you should be able to understand why, when you use it in prediction phase, it is giving you a certain kind of results, a certain kind of outputs. Our POD-based reduced order models helps you in doing it. I mean, they helps you in let you understand why the model is giving you a given prediction. In the last 5 years, we put a lot of efforts in implementing and continuously improving the integration of modeFRONTIer with a Python environment. Why this? Because Python is more and more becoming the common language in our field. I mean, people exchange codes, but not only, people exchange data that is managed by Python codes. So it is really important that modeFRONTIer becomes more and more integrated into this ecosystem. We have many tools in our Python environment in modeFRONTIer. I would like to mention at first the PyFrontier, which is a set of APIs that you can use to drive modeFRONTIer execution from your preferred Python environment. This gives you a high level of flexibility at the end. We also have the PyConsole, which is very similar to the concept of PyFrontier, but it is embedded in modeFRONTIer design space. So you don't need to open external tools. You can leverage your Python skills directly inside modeFRONTIer. At the end, you can use it to train machine learning models. As an example, with your preferred Python library. You can use PyConsole to visualize data using your preferred Python visualization tools. So at the end, modeFRONTIer is more and more integrated in this Python ecosystem. MUSA is our new optimization algorithm. MUSA stands for multi-strategy algorithm. As you may know, in modeFRONTIer we have the pilOPT algorithm, our one-click self-adaptive optimization algorithms. We are considering to evolve the concept of pilOPT to a new implementation, and MUSA is the first step of this new implementation. The first release of MUSA is the first step of this new implementation. The first step that we decided to take in this first version of MUSA is coming directly from a customer request. Because, okay, pilOPT is great, why not you don't open a little bit pilOPT and let us parameterize something, keeping the pilOPT intelligence behind. And this is what we are actually trying to do with MUSA. I mean, it is possible to take advantage of a certain amount of pilOPT smart intelligence, but at the same time, you can decide what are the optimization algorithms that you want to put in the recipe, let me say, what are the RSMs that you want to put in the recipes. So at the end, this is just a first step towards a new evolution, a new version of pilOPT, let's call it pilOPT 2, that will be based and will come from the automated version of MUSA.